Okay, recording the screen now too. All right. Well, let's do this though. So on the final, so I'm working on a Mac, by the way. Are you on a Windows machine?
I'm on a Mac
I'm on a
too.
Mac too.
So this is actually part of your frustration. So I'm going to talk to the school about making a much better information to you guys that if you're on a Mac, it's funky. So right now I'm working in Parallels, so I'm running the Windows version of Excel in a Windows parallel environment on my Mac. That has certain quirks. Like for example, if I wanted to delete all these things, if I highlight them and just hit the delete key, it only deletes the first one,
Okay.
which I don't understand. One of the quirks in the regular Excel for Mac is the sum product formula only works if both arrays are the same direction. So if I had an array that was shaped like this, it was a 2x4 horizontal. If you're on a Windows machine, you could do a 2x4 vertical and sum product the two. On Mac, it doesn't work. So there's a bunch of quirks in Excel for Mac, and there's a bunch of quirks even if you're running Windows Excel in a Windows virtual machine on a Mac. So it's every once in a while when you're trying to do something, it's not you. So just breathe for a minute and think about, okay, what could this be that's not, that's not me. So I'm starting over here. We're going to pretend we've got this same problem. And I actually didn't pre-test this and make sure that it would work. So I'm going to claim the new constraint is 20 miles. We're now going to say that the company wants to put 2 helicopter locations in. Okay. You can kind of follow that idea. So on the final, there is a problem exactly like this. Okay. It's
Okay.
a 2 location distance problem with a constraint. So spend some energy on this one, look back through the video and think about it. Now, everyone starts to make some things too hard for themselves. Out of the problem, just you got your data table, you harvested that really nicely, perfectly. You harvested the constraint perfectly. You picked an area to put decision variables just fine. And then what's your result going to be is going to be down here. So you're going to put a formula in there. I'm going to delete that for the moment. A lot of folks panic when they see this when it's a little more complicated. And one of the things that folks are not doing, and I don't know if you're doing this early in the process or not, but once you plate your spot for your decision variables, pick some numbers that are consistent with the numbers in the data table. So I'm actually going to pick 3462, which is the location of the first one, and 4548, which is the location of the second one. This lets me make sure my formulas are working and lets me do a gut check as I build it. Okay. This one's small enough, it shouldn't be a big deal. So I'm going to find a dist to loc 1, okay? Because I haven't been doing this. I'm going to use the actual square root function. And the x of the first location minus the x of location 1 squared plus the y of the first resort minus the y of location 1 squared. And I think you've got that formula down, right? Pretty comfortable?
Yep.
Yeah, I put too many parentheses in there. And no surprise, it's a zero distance because it's the first location. Duh. Okay. Now I'm going to come back in and make sure that my location 1 row doesn't slide. So row 17 I'm going to lock into place. Something I've seen a lot of y'all do, it's not a bad habit. And out of curiosity, what's your career goal? I don't think you're planning to be a numerical analyst or anything like that. But what's
No.
No.
Yeah.
Yeah, I guess like something sports related. In business with sport, I guess.
That can have some numerical analysis. I mean, so if you have not read and digested the book Moneyball, I mean, part of what changed baseball is understanding you can actually model this stuff. But so there, what I was going to tell you is My personal habit is I only put as many dollar signs into the equation as are necessary. Some folks freeze everything into place. Over time, as you're building bigger and bigger models, that can actually come back to be a problem because you accidentally have something really locked in place and it's hard to find. So I've done that one. I'm going to copy that formula down, and that kind of passes my gut check. It seems like it's about right. Okay. And then I'm going to do a dist to loc2, and I'm going to do it this way. So sometimes I edit the formulas themselves. Sometimes I do the edit and then I grab and drag, but it's the same formula just off of location 2. There we go, and that passes my gut check because the key rock location ended up being a 0 distance, perfect. Okay, then I'm curious, which one was my minimum distance of the two. And I don't actually care which location was. One overachiever in class. Here, hold on, I'll let the dog back in.
Oh, good. Oh, good.
Little knucklehead. Come here, baby. Okay, one overachiever in class not only did this minimum distance, but used the index function to put the names of the closest one next to each one. Like, I don't care, that wasn't the point. Just make sure that we had one of them within a certain distance. So this minimum location distance is the one we're interested in for this constraint. Okay, so one of the mistakes that I've seen made in this class several times is when there's 2 locations and a single distance constraint, everyone over constrains their model and they try to make every location be within that constraint. All we want is any location to be within that constraint. So this column is the one later we're going to compare to this 20 in the solver. Okay. Now that I got that minimum distance, I'm going to do my distance by number of trips to create a weighted total. And there it is. And then obviously we summed it right down here. So that sum that you already had in place, it just happened to land in the same column from your earlier formula. It's right there, okay? So that's it. It's no more complicated than that. I think part of what you're trying to do that's a common mistake is you're attempting to solve the problem. Don't try to solve the problem. Try to identify the relationships inside the problem that solver needs to solve for you. So create formulas that are just simple series of truth and connect them together, and then you can do your thing. So in data solver this time, okay, cool. So this happens to stay the same because I didn't change the layout of your spreadsheet that you had already before. And I'm going to change variable cells. I do need to change this, so I'm going to let it change all 4 of these. And here's the thing. Solver doesn't know what these are. All Solver is trying to do is follow all the algebra you've already built so that that solution is as small as it can be within these rules. And I'm actually going to delete the rule, okay? And it's subject to the constraint. Now I'm going to add it. And like I said before, all we're interested in is these items here, not both of them. Just the minimum one is going to be less than or equal to that 20 that we just made up. And I didn't pre-test this for 2 locations with a 20, so we'll see if this converges smoothly. Honeybee, knock it off. Yes, a pit bull named Honeybee. Jeez, no problem. On a Mac, if you try to run simplex LP, this is a linear programming problem, but I hit solve. That's what you're going to see almost every time. Okay, it's going to give you this error message, and it's going to jump to a different file because it's insane. So on a Mac, if you get that error message, just change to nonlinear and run it as nonlinear. You shouldn't have to do that. So there's 2 big pieces of recommendations I'm giving Oklahoma Christian about this particular class. One is it should not be offered as a 100% online asynchronous course. 100% online is okay, but we should have some required face-to-face lectures like this. Second, we've got to put together like a 1-page tip sheet on if you're running a Mac. Here's all the weird stuff that you're going to hit. So I do not know why it's doing that. But so there we go. So it thinks 503 as a sum is the best it can do. Yep, it got them all within 20. So there we go. It's solved. So that
Okay.
worked.
Okay.
There's a problem just like this on the final. Okay, just exactly what we just walked through. It's got more locations, but it's still two, you know, two solution locations you're looking for. I think it's got 12 items up here. It's got a different constraint, but the constraint again is just for, between the two, what was the minimum? Okay, this one just like that on the final. So spend some energy with this one. Something that is a good thing for you to do. Take the one we just did, make up your own problem. Okay.
Okay. Okay.
Say to yourself, whatever you are, it's hardware stores. I don't know what it is. Pick a thing that you're trying to locate, and just make up your own problem, build one of your own, and see if you can solve it. Do this one again with twice as many resorts with made up locations, and just solve it. That will help you a lot.
Okay.
Okay.
Okay. Okay.
Questions on the location problem?
No, not really at the moment. I guess I pretty much got the hang of it. It's just, I guess the area that I'm just like struggling the most in is just like how to lay it out. Like once I can lay it out sort of properly, then I know where everything goes and stuff like that. But it's just
Mhm.
when there's like variations in the questions and how they're presented, it's just like I'm struggling just to know exactly how to, I guess, lay it out in a way where I'm not like over complicating it for myself and can just see it pretty clearly. So I think that's half the problem is that I am just over complicating it for myself and just making it harder than it needs to be.
Yeah, I think that's pretty common, just so you know. It takes a little bit of time to learn how to just keep these simple. There's a few people in the class that are doing it a little better than you are, but they're creating these spreadsheets that are just gigantic. There's stuff all over the place. And the best solutions look just like the one that's on the page here. There's not much to it.
Okay.
But like on your exam, I showed you the solution here. There is not a simple manufacturing question on the final like this one.
Okay.
Okay, so don't worry about that. This is the distance problem we just reworked, okay, which is cool. This is the mixing question, and I'm using these terms on purpose because it's the main categories of linear programming. So whether you're doing like an investment portfolio like the one in the homework or doing gallons of gasoline, both of those are technically mixing questions. You're creating proportional ratios and then having solver solve it. This one, you're creating a series of triangles and having solver solve it. This one, you were creating a series of if-thens and having solver solve it. But there's not one like this on the final. You can look through the notes I gave you. It'll help a little. There is one exactly like this on the final. I'll put this in the page so you don't forget. Okay. And there's not one quite like this on the final, so let's not spend a bunch of energy on this one. We can take a look at. I prepped an example that is very, very similar to one of the questions on the final, and it's a combination of a make or buy and this what do I want to make problem. So let's glance through your homework first before we get into that. Just make sure I didn't miss something that I was worried about. Yeah, you just didn't do the second half. You did this one just fine on the homework. Yep, and you did this mixing problem just fine. There won't be one like that on the final. This is a mixing problem also. This one's tougher. More people miss this one than exercise 2 by far. And so that the other professor that teaches this topic routinely is Byron Newberry in the engineering department. And he and I do take the time to compare notes after every single semester and try to understand what everyone's getting and what everyone's not getting on the first pass. Okay, then this one, yeah, so this is the combination make or buy plus what do I want to make. There is one like this on the final. Okay, so we're going to walk through an example of one like this in a minute. Yeah, and you extended well. And you did a great job on this one. You just missed a constraint. Okay. What was the demand, and you produced more than your demand asked for, and that's a tough interpretation question. And I actually grade a little more leniently on the final because a couple of the problems on the final are potentially trickier. So if you get close, it's good enough.
Okay. Okay.
All right, let's do the more complicated one. All right. So yes, the fully worked one. Put that one in there. Okay. So we already did that distance one. Now this one, and we're going to work on the layout here a little bit. If I make it one click smaller, okay, is that still good for you?
Yeah, it's fine. Yeah, it's fine.
Okay. Yeah, your eyeballs are younger than mine. So here's the trick. You've already got a data table, and on the final, you will get the questions looking more like this. So the data table will already be in there. Then
Okay.
you've got the word problem portion. And the habit is, let's read through the word problem portion and then go back and start harvesting information out of the word problem and putting it on the page. And the thing that will make this easier on you is don't get ahead of yourself. Just capture onto the page things you know, and then start capturing relationships between things you know. Okay, so you own a company that makes 4x4 Jeep parts. I bought a Jeep last year, so the helpful example is always a Jeep. You manufacture many of your own parts, but you also have the option to buy some of your parts. Your budgeted internal sales price is $470 for each spacer assembly, $660 for each spring lift, and $800 for each combo kit. That means that's what you have for a revenue generation. Your cost to make each is $300, $440, and $580 respectively. The difference between those is the margin contribution by part. You have demand for up to 4,000 spacer assemblies, 5,000 spring lifts, and 3,000 combo kits. And I put stars around up to for a reason. As a model builder, you've got to decide between using your demand as an equals to or your demand as a less than or equals to. Or if it said you must ship at least, it would be a greater than or equal to. Okay, so you just got to think through that.
Okay.
The table below shows the time it takes to manufacturing, coding, packaging, and shipping for each component. You can also buy spacer kits for $385, or either the spring lift or combo kits for $630, up to 5,000 total pieces. What mix of make and buy for your products is needed to give you the highest margin contribution? Which process is your bottleneck preventing you from making more in-house? Okay, pretty straightforward. Now, the way I like to approach one like this is I already know some stuff, right? So I'm going to go back to my problem, and I'm going to recognize that in my problem, my sales price for each is $470, $660, and $800 for the spacers, spring lifts, and combo kits. So I'm going to come in here and say sales price, and I'm going to put it directly under the existing table. Some people like to create a lot of space in their model. It actually can end up being confusing because you've got to, track around a lot of places to find things. So I'm going to do a 470, I'm going to do a 660, and an 800. Next, I am going to take the split second it takes to format this as dollars. The reason I am doing that is it will help you from making mistakes on clicking spots you weren't intending to click. Okay, so now you know these are dollars, these are not hours. Okay. Next, your cost to make each is listed in the problem. I'm just going to say cost to make, and I'm going to put it right here in the same range. Okay, 580. And if we were on a Windows machine, if you didn't know this, those would have automatically copied the formatting above them. But for all the great stuff a Mac can do, it doesn't do that. And I'm the guy that goes back and forth. The Mac is my work computer. It's the one I happen to have out today. I would prefer to be on a Windows machine for this. The difference between those is the margin contribution by part. Now you can stop and think to yourself, do I want to go ahead and create a row for margin contribution, or do I want to do that at a different time? It doesn't make a big difference. You can keep capturing data. Something I probably would do if it was me is just go ahead and create a margin contribution, knowing that that's the difference between the two. Okay, I keep reading the problem. The difference between those and margin contribution, you have demand for up to, oh, okay, very cool, 4,000, 5,000, and 3,000. Now this is where I'm going to break from something I said a minute ago. I'm not actually going to put it right here because I know that here in a second, I'm going to have my buy cost and I'm going to have my buy margin contribution by part, right?
Yep.
I'm anticipating that. Now, instead, I'm going to put my demand down here. Okay, so I'm going to come down a little bit because I already read the problem once. Okay, and again, even if it's not dollars, take the time to go ahead and format the number in a way that makes the most sense. Because if you went back and formatted this and all of a sudden you went, hey, I got a comma, and a no comma, you might realize, oh, I meant to type 3,000, I accidentally typed 300. It helps troubleshoot things much, much faster if you have things formatted right. Okay, so continuing down, I can buy the spacer kit for $385, very cool. Or I can buy either one of these for $630. Okay, I'm going to format them. Okay, and I'm going to stop before I keep reading. And in this case, my sales price minus my buy cost gives my buy margin contribution, right? Very cool. It's very exciting. Okay. Now, next piece of information, up to 5,000 pieces. So I can only buy up to 5,000 pieces. So I've got my first standalone constraint. I think this is plenty of room. I'll just put it right here. If I could spell constraint. My buy maximum is 5,000. Okay. Okay, that looks like we've captured all the data. Now, this is where some people start outsmarting themselves. Don't outsmart yourself. Your spacers are already in this column, in column E. I think you already did a good job of this with the smallest models, but I'm going to come down here and I'm going to create my decision variable area. And I'm going to say I've got a certain amount of make, a certain amount of buy, and I'm going to put this table directly in line with the other one. So my spacer assembly information is going to go straight down here. Spacers, springs, and combo. Okay. And then I'm going to highlight this so it's easy to find. I had somebody in a prior class think that this was a silly step. And I'm like, that's cool. Wait until you're working with an Excel spreadsheet that's 10,000 columns wide and 60,000 rows deep. You're going to want to highlight stuff. Okay. You don't sound like you're going to go into that end of the world. I don't intend to, but occasionally I end up handling a sheet that's like that. Take the time to do stuff like this. So this is where I'm going to put my decision variables. Now remember, as soon as I get to this spot, put some numbers in here that are in range. So I'm just going to put 1,000, 500, 1,000, 500, 1,000, oops, 500, just to have something in there to chew on, okay? Now, we got to think through all the other stuff that we need to constrain to. So we know we want to find out what's the profitability of this because we want to maximize profitability. And we know because we were given hours available in each department, we need to sum up how many hours get used based on how many of these we produce. So I'm actually going to start with the dollars because we're already down kind of in this spot. And I am going to keep it all visible. You could build this all into a single cell. That can be hard to visualize, okay? So don't feel like you need to. I call it make profit and buy profit for spacers, springs, and the combo. So I could build a formula that adds all this up in one fell swoop. Until you get better at seeing this stuff, that's probably not a great idea. So I know if I build a similar table like this, I'm not going to highlight it, but I am going to put little boxes around it, just so it's easier to store in my brain. So I know that the profit for spacers is how many spacers I make times the margin contribution for making, okay?
Yep.
It's that simple, right? And in this case, I can just copy straight across because it picks up the same two spots. How many did I make and what was the margin contribution for them? For the buy, I'm going to do the same thing. I'm going to click on how many am I going to buy of that one, and it's times the buy margin contribution. Very cool. Bingo. I'm going to copy those across. Now, I'm going to skip down. Let's see here. I want to organize this. I don't want to get too... I'll just, you know what, I'll put it right here. So my objective is going to be max profit. And this is simply going to be the sum of all those separate contributions. Okay? Again, yes, I've got it labeled. Yes, I might lose it in a giant spreadsheet. So I'm actually going to highlight it green and put a box around it. Now, while I'm down here, I just talked about how many I'm going to make and how many I'm going to buy. I have two constraints around this, right? One is I've got a certain amount of demand. Okay, so I've got this demand profile. So I'm going to use this row we didn't use a minute ago. And I'm going to make an actual total. It's going to sum the make and buy of the spacers, sum the make and buy of the springs, and sum the make and buy of the combo. Okay? So that's going to be a constraint. Okay? Right? So in this case, I'm going to interpret the way the problem was said as each one of these must be less than or equal to that demand number. So once I hit that demand, I don't want to keep making them because I don't have enough sales to support it. Okay? Now, I'm just for the sake of this video, I don't normally do this in my own models, but I am going to highlight the constraint areas in a pale blue, just so they're pretty easy to find again. You know, so that's a calculated piece I'm going to need to compare to something. I also know that I've got a buy maximum, right? So, and you can put this wherever you want. And this is, I'm going to do this by actual, and it's going to be the sum of these three. Okay, turn that into a number. And I'm going to highlight it blue as well, so I don't forget to use it. Okay. Now I got to take a look at my hours, right? You could use a sum product and do this all in one fell swoop again. I'm going to leave them each visible just so you can visualize how this is working. Okay.
Yep.
I'm going to say spacer hours, spring hours, and combo hours. Okay. And in this case, it is my spacers times my manufacturing, right? I copy that down, and that would be how my spacers are. Whoops, I didn't do my dollar sign. Oh my gosh. Okay, now my brain's awake. Yeah, okay, there we go. No, my brain's not awake. Freezing the wrong one place. I'm such a knucklehead today. I'm gonna get beat up in jiu-jitsu tonight. All right, there we go. Now I made it work. So that's the hours that we've got. The spring hours are the same. In this case, I could just copy straight down. And part of how I pick this layout is I know that if I followed this layout here, I can just repeat it, and it's easy to copy paste across. Okay. And then I'll do the total hours. You don't have to do that. You could build a formula that encompasses all that stuff directly into your total hours. Okay. Now, before we even go to Solver, I like to stop here and just kind of look at it. So with those dummy values I put in that I thought looked kind of low, I'm actually already past my manufacturing hours. Wow, so I'm gonna need to buy some things or I can't get very close to my demand, okay? It's an interesting observation, right?
Yep. Yep.
So I'm gonna highlight this blue so we don't forget it. All right, what do we think? Do we think we got all our constraints? We've got total demand constraints, we got the purchase constraint, we got the hours constraint, we've got a profitability. I think we're ready to open Solver. And something you will find is occasionally you'll open Solver only to suddenly realize as you're clicking around that you forgot something. That's great. Happens all the time. I don't know what spreadsheet I recycled here. Okay, so my objective is this max profit. You got to make sure you pick max. The number one mistake on the exam was, at least on one problem, more than half the class picked the wrong thing between max and min, which was an interesting observation, I thought. Subject to changing these variable cells. And then we've got constraints. So let's add them in. So always, always, always put the calculated value in the left and the integer constraint value in the right. Yes, it actually will run most of the time as long as you have the sign facing the right way. Once it's got a bunch of constraints in there, it'll choke all of a sudden for some reason, and I don't know why that's the case. So I'm going to kind of work down the page top to bottom so I don't miss stuff, and this is why we highlighted in blue. So my hours need to be less than or equal to my available hours. Add another one. My total actual made needs to be less than or equal to my demand. And my purchased actual, my buy actual, needs to be less than or equal to my buy maximum. I'm going to click OK. Now I'm going to do it just to show. This one probably will not run in linear. This is a linear problem, technically. Ooh, it ran. I'm actually shocked. Keep the solver solution. And now let's look at it and see what we think. All right, so if you were going to be typing some observations about this, what's some funky things you think you see in here? And I did pre-read some funky on purpose.
Not making any combo kits and not buying any spring lifts.
Yep. And I also think it's interesting. We just don't have many spring lifts in the mix at all, right?
No.
Yeah, so that's interesting. Now in our processes up here, which process is constraining us? So it's right here. So it's the only one. So something that makes this easier to see. So there's not a part B in the exam, I don't think. I'll email you if I'm telling you something incorrect. But sometimes on a problem like this, I'll ask for a, hey, unconstrain the constraining process. You know, and so we can see what a higher profit margin could be. But the slack time that's left, and as a manufacturing guy, I think in terms of slack, okay? How much slack do I have to make more stuff? So there's no slack left at all in the coatings process. So that's kind of interesting. And if you look in here, I very intentionally loaded coatings up where it takes a lot of time. Okay? And that's actually part of what's driving this, you know, the spring lift not being used very much and the combo kit not being made at all, is the combo kit's margin contribution is only $220, just like the spring kit, but it takes 9 hours in the coating phase, 3 hours in packaging, an hour and a half in shipping. Man, I wouldn't want to make that in-house either. I'm going to buy that. It's just too resource intensive for not much profit. So that's kind of how you would look at, you know, what the constraints would be. So you would want to be able to comment on some of that stuff on the final, but there's not a part B where you fix it and make it better.
Okay.
So how do you feel about this one?
Yeah, pretty good at the moment. I guess it seems like they're all pretty simple. I guess formulas you need to put in for your, I guess, constraints to find the answer, which yeah, when it's simple like that, yeah, I can understand it pretty easily. It's more just yeah. I guess the
Think
hardest
about it
part
as
is yeah,
follows.
just setting it up again.
That's it. And on the final, like I said, there's already a table in the page. Try to branch out off that table with what's in the words. Okay. And do it just like what you just said. The formulas are pretty simple. You know each one of these individual items inside and out. You wouldn't be where you are in school if you didn't. The trouble is you're trying to look at the whole picture all at once. Don't do that. Read the problem, understand the problem is a big picture, but then go through and just step by step identify what do I know. I know the sales prices. I'm going to put those in. I know the cost to make. I'm going to put those in. You know what? It just made a comment in there that margin contribution is the difference between those two. So I don't expect any new info. I'm going to build my first formula. Okay. So just slowly nibble through, stacking each simple item on top of each simple item. And that's the easiest way to get to an answer that's usable. So,
Okay.
what do you think?
Yeah, that helps. That helps a bit. Yeah.
Yeah.
Um,
And what I suggest is, I mean, take a look at these, and then there is some new material. There's 2 problems on the final. I think 3 in the homework. There is one really hard problem in the homework that very few people get correct. You have to step through an enormous number of these formulas and get them all right to solve the problem. So when you get to the one about balancing a boat, balancing a ship, and you can't seem to get it all to work, don't worry. No, nobody does.
yeah.
So I give a lot of partial credit on that one. But there is some new concepts where there's large tables solving for a large table. So what I suggest is the next couple of days you spend some energy getting your arms the rest of the way around Unit 2, these example problems that we just worked through today.
Yeah.
Take a look back at only these 2 types of problems. So like I said, on the final, the only 2 types from Unit 2 that you're going to see. You're going to see one exactly like this, where it's a 2 location optimization with a distance constraint. Okay, there'll be one of these. So spend some energy on this, build one like it for yourself.
Okay.
Then there's one just like this on the final. It's a make or buy with a manufacturing process. It's a different process. Now I will tell you, there's only I had you on this one. I intentionally made it big and complicated. So this one I did, but there's 3 different items to make or buy and 4 processing steps. The one on the final only has 2 items to make or buy and 2 processing steps. So it's smaller.
Okay.
But the rest of the constraints are the same. The hours concept is the same. The demand is the same. The buy constraint is the same. The idea that you should build a table like this, and a table like this is the same. So I think you spend a couple of days on that and see if your comfort level is getting higher. If not,
Yeah.
I'll go through it again. I'm perfectly happy to do this some more.